So today I think I'm probably going to use all three. I just like coloring. They want you to talk about congruent quadrilaterals. So they give a definition of congruent quadrilaterals. Basically, if they have corresponding parts that are congruent, then they are going to be congruent. Now, the proof for these have to be done with one of the two theorems that they give you on the other side. Either done by side angle, side angle, side, or by angle, side, angle, side, angle. I think it's easier to understand these if you actually just look at what they have here. So when you're given a side, an angle, a side, an angle, and a side that happen all consecutively, and you have the same thing over here, then they're going to have to be congruent because the only thing you've left out are two angles and one side. Now, if they match up with these two angles, then this side is going to have to be the same length as that side right there because we've already said that those two are true. So that would mean that this would have to equal that, and therefore you would have all the corresponding parts that they talk about. The same thing works with angles. If you end up having three angles that are the same and two included sides, like we have over here, then obviously, because the angles are set right here and right here, obviously they're going to meet up at the same place over here, which means they're going to have to be congruent. So that's the way it works for side, angle, or angle, side, angle theorem. Now, they have proofs for these, like this proof is here, how they proved it, and this proof is going to be on exercise 34, but we're not going to worry so much about proving that they're true. We're just going to take them at their word because it's easier to see that they're true. So there's that. And when we do the classwork video, I know we skipped section 6.6. I bet that didn't shock you at all though because it was blue. So when we do the classwork video, it'll probably be kind of short too because it's not really used that often about quadrilaterals are congruent unless they're going to be special quadrilaterals, in which case we talk about special quadrilaterals, not just regular quadrilaterals. So there's that. We'll see you, or you'll see me in the next video.